Hi, everyone. Today we'll be presenting our paper, Auditing for Gerrymandering by Identifying Disenfranchised Individuals. As a brief background as to what gerrymandering is, it's essentially the act of drawing districts to favor a particular political outcome or population group. In the figure, we can see that perhaps we have a toy state of 50 people where there are 60% blue voters and 40% red voters. Nevertheless, it's possible to draw a map where there are 3 red districts and 2 blue districts, so essentially red sends more representatives to Congress, even though they are a minority in the state. Our motivation for the framework we use is because courts care about fairness to people, not parties. In the 2018 case Gill v. Whitford, the plaintiffs tried to bring up claims of partisan gerrymandering, but the justices ruled that the case was about group political interests, not individual legal rights. However, Justice Kagan noted that a plaintiff could produce an alternative map consistent with traditional districting principles, under which her vote would carry more weight. And this would give the plaintiff standing. This would show they had been harmed and could thus successfully bring a claim to court. So to precisely define our framework, we first have to make some definitions. First of all, a VTD is essentially a voting tabulation district, which is more or less election precinct, the smallest level at which elections are organized. Any claim that a VTD is packed or cracked in a given districting must refer to a counterfactual districting called a comparator. And there are 2 forms of gerrymandering that might occur with respect to this comparator: cracking and packing. Cracking is what's demonstrated on the left-hand side. So we have 16 VTDs arranged in a 4x4 grid. There are 2 parties, 1 red and 1 blue. Now, the original districting is on the left and the comparator is on the right. We can see that the central blue VTD with 4 voters in the left districting is cracked relative to the comparator at the right, because the blue VTD in question receives blue representation under the comparator, but not in the original districting. Similarly, we can see a case of packing when we consider this whole idea of comparators. The top left red VTD with the 1 voter in the left districting is packed relative to the comparator at the right, because in both the left districting and the comparator, the red VTD is located in district in which red wins, but the win of the comparator is achieved with a much lower margin of victory. Then we can precisely define a gerrymandering score by averaging over all the comparators the number of cracked plus the number of packed individuals. In this figure, we can see which areas of North Carolina are most gerrymandered, where the VTDs are shaded by the gerrymandering score per capita. Finally, the second part of our framework, now that we've computed this gerrymandering score, is to compute a witness. The reason we need a witness is because, sure, perhaps a map may have a high gerrymandering score. Nevertheless, one may claim that gerrymandering is a necessary result of the spatial distribution of voters. So if we compute a different map with a lower gerrymandering score, but that still preserves basic properties like compactness and population balance, then this is strong evidence that the map under audit is a gerrymander. One example of an audited map is below. In the 2016 map, we have a gerrymandering score of about 1.1 million, but we managed to compute a witness of just about 570,000. So in conclusion, we created an interpretable localized score for gerrymandering. Then we designed a simulated annealing algorithm to audit districtings for gerrymandering. And we found in the 2016 North Carolina election map that there were substantial levels of partisan gerrymandering.